Two terminologies of energy are very essential to understand. And the first one is the system, the terminology called the system. The system is the object of study. Whatever you are trying to know more about, that is your system. And the second terminology is the surroundings. So anything that is not a part of the system is a part of the surroundings. We can draw a very simple cartoon for this. If this is the entire universe, and this is the system you are trying to study, that is the experiment you're trying to perform. So this is the system. Anything that is not inside this system, anything that is not a part of this system, then would constitute the surroundings. Because the universe would be equal to the system plus the surroundings. Why are we interested in knowing about systems and surroundings? This is because whenever we are performing a chemical reaction, we want to know whether our system is releasing energy or whether our system is absorbing energy. Two other terminologies of energy that are very essential are exothermic and endothermic. So what do we mean by them? Well, we always want to know whether our system is losing energy or absorbing energy from the surroundings. If the system is losing energy into the surroundings, then that type of system is said to be exothermic. On the other hand, if the system is absorbing energy from the surroundings, that type of system is said to be endothermic. Let us apply this thinking to chemical reactions. A chemical reaction where the reactants, the things you are trying to react, they have higher energy than the products you are trying to form. That means the only way the reactants can become the products is by releasing energy into the surroundings, because the energy of the reactants will have to come down to the level of the products to be formed. That type of reaction is called exothermic reaction. So remember that. You began with the reactants, you ended up with a product, but the reactants are too much energetic. So they have to lose some energy to become the products. On the other hand, if the reactants are lower in energy than the product to be formed, the only way the reactants would become the product is if they absorb some energy from the surroundings. Let us take a look at some simple real-world examples. Identify the following changes as exothermic or endothermic. Water freezing into ice. If you are thinking this is an endothermic process, you are wrong. Why is it not endothermic? Why is it exothermic? Well, you are beginning from a liquid. You are going to a solid. In the liquid state, the particles are freer to move. They have higher kinetic energy. In the solid state, the particles of the solid are not as free. They have lower kinetic energy. So, the only way the liquid will become the solid is if the liquid loses some of its kinetic energy into the surroundings, which means this is an exothermic process. Let us look at the second one. Propane burning. If propane is burning and you move very close to it, you can feel the energy being released by the propane that is burning. Actually, a very simple way to remember this is that anything that involves combustions or ignition would be exothermic, because if you move closer, you can see that the system is radiating energy, giving off energy into the surroundings. The third one, isopropyl alcohol evaporating from skin. Well, if you apply rubbing alcohol, that is isopropyl alcohol, if you apply it on your skin, it will absorb energy from the surroundings and from your skin, and it will evaporate. So if you look at the direction of energy, you will see that the energy is going into the system because the isopropyl alcohol is our system. Since the system is absorbing energy, this is an endothermic process. This could be a little tricky to do, but the easiest way to do this is to first identify your system and look at the direction of energy.